Alrighty. Well, first off, thank you everybody for joining us this afternoon or morning, depending on where you are in the world, or maybe evening. Very happy to have you here and really excited to present this webinar to you today. And also with two great partners here, Inray and InfluxDB. Right, so as the title says, we're going to be talking about deploying Industry 4.0 apps to edge devices and building a whole pipeline from the edge device itself, reading information, pushing it up to InfluxDB, and then all the way up to Grafana for visualization. And all of this linked together using containers, which is why we all came here together today. So first, let's do a quick introduction of who's with me. So Zoe Steinkamp is here, and Jan Jebens, and I'll let them do a quick intro about themselves.
Sure, I'll go ahead and go first. So my name is Zoe Steinkamp, and I work for InfluxDB.
My name is, you can see, is Jan Jebens. I'm working at Inray as a pre-sales consultant. So I'm at Inray for 12 years now. And before that, I was out in the field implementing different IoT projects based on our software products that we provide at Inray. And later on, I joined the pre-sales team, and now, I'm happy to have you here on the webinar today. Thank you.
Yeah, and my name is Heimerman. I'm also a field application engineer at Portainer. And then I just want to go over, just so we have a context of how these all link together, right? So now we're going to cover OPC router from Inray, and also feel free to talk a little bit about Inray as well, Jan. How we build the applications that actually take the data, move it, transform it, whatever, and move it into the database. And then we'll conclude then by showing kind of like a full large scale deployment of OPC router, which will then push into Influx, which will then be displayed in Grafana. So just so we have like a little bit of context where we are, and then I would give it over to Jan so that he can show us how OPC router works.
So everybody should now see my screen actually. So maybe just shortly on Inray, I already said in the beginning that we are a software provider focusing on industrial applications. So in the Industry 4.0 context, we are building applications. We do offer several products ranging from production management, on-premise production management in the cloud. And then, of course, what is the focus on today, OPC router as a central communication platform offering a wide range of connectivity in the industrial environment. So we develop our software products centrally here in the north of Germany, but we also have partners worldwide, and we offer also consulting and realization on site with our project development team. So as I said, it was 25 years ago founded in Germany, but today we have partners, 30 distributors in over 60 countries, I think, distributing OPC router and providing support. So when it comes to OPC router, should be no problem to have support in your local language. On OPC router, as I said, it's basically a central communication platform. It is software based. It's natively running under Windows, but it can also be deployed in a Docker container under Linux. And we also provide a Helm chart for the deployment in Kubernetes. What it does, it connects systems from shop floor to top floor bidirectionally. We have cloud connectivity, several database systems today focusing on Influx. We can connect also printers. We are very strong, grown over the years, hence the name OPC router in the OPC environment. Everybody who's familiar with OPC UA, it's quite a standard with some complexity, and OPC router covers many parts of the specification. So that's certainly a focus also when it comes to companion specifications, but also running OPC router as an OPC UA server, being able to import companion specifications online from the OPC Foundation or offline. So that's why the name OPC router. This is a picture where you see, just to make clear what OPC router is, as a middleware connecting different systems from different layers. So we have the cloud, we have databases, native integration to SAP based on SAP communication libraries, but also REST web services, OPC UA as a server and a client. When it comes to REST, we can also provide a RESTful application as well as being a client. We do have a lot of tools for data manipulation, ETL tools. You can use scripting pretty much without boundaries. Nevertheless, OPC router is thought to be a no-code platform. So you don't have to be an expert in either PLC programming or higher programming languages in order to use OPC router. That's the idea. Make it as easy as possible. I will show the use of OPC router using one instance. That usually makes clear how OPC router works and gives you a picture of how you operate it. But when it comes to orchestrating, managing multiple installations of OPC router in your network, you have the challenge to deploy project configuration changes or updates on the version and so on. And that's then where Portainer takes over to orchestrate that challenge. And then finally, when Andrew has deployed all the instances of OPC router, the data example that we are prepared for today will transfer data directly to the InfluxDB to the cloud, and then it will be pictured by Zoe. So that's the use case. And we used a more realistic example from a customer from us. It's a very small part actually of a paper towel machine. So the investing unit to have some more realistic data. And whenever you're interested, of course, there's a lot of information on our webpage, also tutorial videos and so on. But let me now directly jump into OPC router. Regarding the architecture, OPC router, when you install it, either on Windows or deploy in a Docker container, it's separated into two parts. So you see the web user interface here. In the background is running the OPC router runtime, which will then transfer the data. So in the management, you configure the source and destination systems, and you design the data flow. The data flow.
I'll just let me one quick for a second, Jan. If there are any questions that do come up during this webinar, please feel free to type them into the chat. We'll answer them at the end for sure. If we don't see them during the demonstration, but please feel free to do that.
Exactly. And what you do is you design data flows. It starts certainly options. There are some features that could be relevant, like redundancy. OPC router can run as a pair in redundant mode, primary and secondary system. We have store and forward. Once you lose connection to the destination system, OPC router would store that information and then push it forward once connectivity is reestablished. Regarding the plugins, I already gave a quick overview in the slides. There are several over the years here, somewhat grouped by topic, if you want, the OPC section and so on. And basically what you do if you want to communicate, exchange data between systems, you have to configure it. That is, for every system, it's somewhat the user dialog is different, but it is always something like that. As if you want to configure Influx, you get a dialog here. You put in a working name that is displayed when working with OPC router. You probably have a host as a destination system. So when you set it up, Influx gives you that URL, the type of authentication. We saw the token earlier. You copy paste it in here. You have to put in an organization name, also provided by Influx, and then you define the bucket. So basically the database in old time speaking. And once you do that, of course, that's working fine. The next step would be I have a connection. So I have different types of data flows. Sometimes I have thousands, 10,000s of connections. That would be a template instance version. In this case, I'm using a regular connection. So a data flow is then designed. I say, okay, I want to transfer some OPC data, which I retrieve from the machine and send it maybe to Influx as an example. And then a connection is created by name here in that folder, and you have a workspace here in the middle. And what you do is on the very right side, you have transfer objects, that's sources and destinations for your data flow. And all the way down, you find triggers. Those are used in order to execute a connection. So starting with some source data, I choose some variables, OPC data in the background, and all those values here are being read from an OPC server simulating the machine. So those variables are supposed to be transferred to Influx. And next step would be you drag in the destination system. So when you double click it, of course, you choose the correct cloud and you provide a measurement. So maybe something like this. In this case, when you have set up Influx, you don't have to provide a measurement online. You can just type it in as free text here. OPC router will automatically create that measurement on Influx side once there's a first transfer of data. And then you have tag keys in order to identify your data for the analysis later on. In this case, I will provide a machine ID. And that's basically it. And then the field keys, which is the data itself. So the data that is being stored for analysis purposes. So you just provide names, basically. And that's quickly some speed here. And the tension of the paper, I guess. So, and that's it. I defined the bucket, the measurement, the tags, and the fields. And now, maybe I use a constant quickly here. It is the embossing unit. Yeah. And that would be the tag then. So you quickly match the source and the destination. And then when it comes to tools, I can just draw a line here, and then the matching is done automatically. So this would be a very simple, easy way to create a data flow, as an example, in OPC router. Finally, of course, I need a trigger. So I can choose a variable trigger here and looking at the value of maybe the speed. So every time that value changes, this will be executed. You can combine any transfer object here, no matter what kind or how many. The data flow is always straightforward from left to right and then top bottom. If I want to make the changes productive, so I pass it over to the runtime environment of OPC router. It switches to the monitoring, and then you see here, OPC router will initialize connection to OPC and the destination system, which is Influx. And in the monitoring, you find each transfer, especially important if you want to analyze the data, if you're running into trouble and so on. So you can always see what values were transferred to at what point of time. So the monitoring gives you complete insight and transparency of what's going on inside OPC router. That is a very easy example. Of course, can be much more complex, but I hope it gives you an overview how OPC router works and how you use it. So I guess that would be so far my part from OPC router. And then I hand over back to Andrew, I guess.
Yep, perfect. Yeah, so now what we're going to do is basically take this exact example. So what from OPC router, we can actually export this program. And then because it's containerized, we can actually use Portainer to massively deploy and configure the OPC router to basically be sent out to a complete fleet and be configured to the specific needs per device, right? So let me just go back here quickly and share my screen. All right. So for those of you who are not familiar with Portainer, Portainer is a container management platform. So it means we can manage Docker, Docker Swarm, Kubernetes, all with a UI that's intuitive and easy to use. So it requires less work for deploying applications, managing applications, especially in industrial environments where you don't always have technical folks who are able to go into the terminal and run different commands. But so as you can see here, when you enter Portainer, you're presented with your available environments to be able to manage. So if we click into this machine here, for example, we get an overview of all the things that are running in it. It'll just take a second. So all the containers that are running in it, you can see logs from the containers, etc. Portainer gives you this overview. You can start, stop, and and remove containers and do all of those controls from here. So let's take in the example that we're onboarding a bunch of new devices into an industrial environment. Traditionally with Portainer, if you've used it before, you're familiar with adding in a single environment at a time and connecting and then being able to manage that environment. For our industrial applications, we've developed an auto onboarding feature, which allows you to generate a single script that includes different tags, for example, or role-based access groups and device IDs. So you could imagine that you're rolling out to a bunch of different devices. You don't want to have to go to each device and run a new script each time. So here, Portainer actually generates a script for you that can be basically brought into a golden image or a boot script on a device like a PLC or something like this. Any device with Docker at the minimum, and you can run it, and Portainer will then will receive information to connect to that particular machine. So you can basically have these machines pre-configured before even being shipped out to your sites, and all that someone will have to do is essentially turn the machine on. The machine or the device has this Portainer agent then installed, and this Portainer agent basically handles how to run the jobs, so how to run the containers and how to communicate with the server where you are managing your devices. So if I go here and I will tag them with a particular group, actually, I'll do like this. And these devices will be automatically added to Portainer and assigned to an application group, which we call our in Portainer edge groups. So we can see that automatically, now that those devices were added in, we have 10 devices dynamically associated to this OPC router group. And now to this group, I can deploy the OPC router. So what Portainer uses, like all container engines or Kubernetes environments, is we use Compose or some type of deployment manifest for Kubernetes, which we can either upload, we can edit it directly here in Portainer, or we can even use a Git repository where it's stored, which is what I will be doing for this. So I'll just name that OPC router deployment. I'll select the devices that we just added. And here's where we're going to actually tell Portainer what to run. So I've created a Git repo, which contains a Docker Compose that defines what project to run. So this same embosser project that I have here, as well as configurations for each of these devices. So what Portainer is able to do actually is look into the Git repository that we provided, pick out the deployment, excuse me, the manifest or the Docker Compose, which tells Portainer what containers to deploy. And it will also then pick the application for OPC router, as well as the configurations for each device based on IDs. So if I copy this link and I go back to Portainer, I can paste it in here like so. Then what I can do is select the branch I would like to use. So you could also think about using this for testing or development branches as well as production. And then I'll just fill in where the Docker Compose is located. Now, in order to pass over the configurations, I'll just specify the configs folder in the repo where it should look, as well as where those configurations should be copied on the device itself. And I'll just say match the device name with the file name for the configuration. Just add the credentials here. And basically that's it, right? So what we've done here is created a template or created a stack that looks for the deployment information in Docker Compose, tells Portainer which configs should be pushed over with the deployment, and we can simply then now deploy to all of those devices at once. But you can see that within a few seconds, they are able to pull the images down and the deployments are being sent out massively to all of the devices, right? So if we go in here, we can also check to see that these are actually running. We go in here and we can see, all right, OPC router is actually initializing and is going to start up the application for the embosser like we just showed. It's also pulling in the configuration from the Git repository. And then if we go then to the Grafana, we should start seeing data from all of these devices. So I'll just end my screen share and we can go over, Zoe, if you want to show the Grafana.
Awesome. So here is the Grafana dashboard that's showing our data. So let me go ahead and set this to be the last 5 minutes or so. There we go. Much better. That was just for when I was testing. So as you can see, we've got a minimum temperature on our roller. That looks like that's that drop right there. That's that 0 temperature. The max is 43. That's the highest we've gotten. You can also just kind of scroll over and see an average here. We can see, you can clearly see that something went wrong here, but overall it looks pretty good. And you can kind of see that replicated in all of our other graphs as well. As the roller pressure drops to 0, that's probably because the machine was most likely shut off. Maybe something went wrong or they just needed to restart it. And also you can see that the paper thickness kind of gets a little wonky when it first comes back on as well. But our average thickness is 2, and our web tension paper, sorry guys, I have like there we go. Now I can see it better. Same with the roller speed. And this shows our last 5 values here. So these are the last 5 that we received, which all look pretty normal and within our averages, which makes sense because this drop here was a little bit more than 5 values ago. And we can go ahead and refresh this page and we'll kind of see everything start to move to the right. You'll see, we'll still have that minimum temperature of 0 till this one drops off basically. But again, you can see your most recent 5. But yeah, this is just a very basic visualization to get an idea on the health of things, how they're looking. And actually under the hood here, this is pretty straightforward. For people who aren't super familiar with Grafana, it can be a little to take in, to be honest. But basically what we did is we did this with a SQL query. We just created it in the coder. There is also a builder that allows you to kind of, I'll copy the code and show. So basically this allows you to build out your query. Sometimes this works well, sometimes it doesn't work quite as well. We find it tends to break down on the more advanced queries. So for this, we just prefer to use it within here. But yeah, you just run your query and you'll get a graph like this if you've got it set to time series, which Grafana offers many, 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 many options. All the visualizations you could ever ask for. That's kind of something that people complain about with their UI sometimes. It's just that it's a lot to take in, to say the least. But yeah, this is just our basic dashboard, and we'll go ahead and refresh. You can actually set this up to auto refresh. So like auto refreshes every 5 seconds or something. I just didn't do that for the beginning of this. And clearly I broke my graph when I touched it, but that's fine. I can go back and fix it later. But yeah, this is how it would look in the end. And it's pretty straightforward to set up the integration with Grafana and Influx. Really quick, I'll just show what this looks like. So basically you select a data source. Here, let me try to create a new one. Yeah, there's add new connection. We have a pretty good relationship with Grafana. So we basically have a specific Influx connection here, which allows you to use our 3 different versions. I've been using InfluxDB 3.0, so I've been doing SQL. And extremely similar to UPC router, you're just going to give it the database name, that same token, as long as it was a read-write token, as in OPC router can write and Grafana can read, you're good to go. And then basically you just save and test. And it's really, really straightforward. Like this is super simple to set up, thank goodness. And yeah, once you have it, you can see it within your data sources. So you can see I have one here for a different project with Influx. Grafana automatically creates most of these here for you. These are all default ones. And then these are all my other Influx ones, including the Portainer one as well, which yeah, you can see I've set up with the URL. Because my token's been configured, it kind of hides it like that. The database name was Portainer. And yeah, that was pretty much all I had to do to set up and get going. It was very straightforward. And then once you do that, you have your dashboards where you can put all your visualizations. Or if you're me, you can also break them. But yeah, that's basically how this all looks in the end. And yeah, this decided to reset the last 7 days. There we go.
Yeah, so basically what we just did there is essentially just build a pipeline in a few minutes. There we were using obviously Influx in the cloud. That could also be the same if we were on premise, like the whole thing. And again, thank you from my side. And thanks to Jan and Zoe for joining today.
Thanks as well. Great that we could be here today.
Thank you for hosting, Andrew.
Yes, so hope you have a great rest of your day. If you're in Germany or parts of Europe, have a nice holiday tomorrow. Yes, we hope to hear from you.